Okay, so we're going to talk about heart valves. So if this is the right atrium of the heart, and this here is the right ventricle, and if I just draw this in a sort of box shape to make it look kind of simple, blood flows from the right atrium down into the right ventricle and then gets pumped up through the right ventricle to the pulmonary artery where it's taken to the lungs. And then it's going to come back to the heart on this side into the into the left atrium, and then it is going to enter the left ventricle before then being pumped up through the vessel to the aorta, where it will be then taken to the body. So in order to make sure this flow of blood is maintained in this circulatory pattern, we're going to have various valves in the heart. And one of the set of valves that we have are called the atrioventricular valves, which run between the atrium and the ventricles. So these here and this here is called AV, atrioventricular valve, or valves. So what we need to be able to establish is when these valves open and close. So if the right ventricle fills up with blood, then the pressure in the right ventricle is going to be high, and if the pressure in the right atrium is going to be high, and the pressure in the right ventricle before it's actually had any blood taken into it is going to be low. So in this scenario here, the valve is going to be open. So if I just draw that over here, if I have my atrium and down here I have my ventricle, if I have a high pressure in the atrium and a low pressure in the ventricle, I'm going to have an open valve. So I'm going to write open here like so. Then what's going to happen is, as blood rushes from the right atrium into the right ventricle, as the right ventricle contracts, I'm then going to have now a higher pressure in the right ventricle than I have in the right atrium, which is now going to be lower. And so in this scenario, the blood is going to not be able to return, as the valves only are able to open in one direction, so the valve will close. So if I draw this over here, if I have a low pressure in the atrium and a high pressure in the ventricle, I end up with a valve that is going to close. So let's just mark that out here as the scenarios that will arise. Okay, so what I can do then is I can look at a pressure graph here. So this is my pressure in kilopascals, and this is going to be time along here like so. So if I was to plot the pressure in the atrium with a straight line, so a line without any dots in it, the pressure in the atrium is going to rise as it fills up with blood and then contracts, and it will pressure in the atrium will lower as the blood enters into the ventricle, and then as the heart then as the atrium then fills up with blood again, it's going to be a slight increase before then the process starts again, the cycle starts again. So this phase here, where the atrium is contracting, is called atrium or atrial systole. This part here is where the ventricle is going to contract, so it's called ventricle systole. And finally, this part here is where the atrium is refilling, and so this is going to be called diastole. Okay, so now with the dotted line, I'm going to draw the ventricle pressure. So the ventricle pressure initially will be quite low, as the pressure in the atrium is high and is pushing blood into the ventricle. And then the pressure in the ventricle is going to steeply rise as it fills up with blood and contracts. And as it contracts and it leaves through one of the arteries, it's going to lower before returning to its original starting position. So what we need to have a look at then is various locations on this graph. So let's say, for example, a point in time here. What I'm going to be doing is I'm going to be mapping out which chamber has a higher pressure. So in this scenario here, I'm going to have, remember this line here is representing my atrium pressure, and this dotted line here is representing my ventricle pressure. So my atrium pressure is in this location here currently higher than my ventricle pressure. So therefore that is mimicking this scenario here where my atrium pressure is higher than my ventricle pressure, which is lower. So at this point here you would expect the atrioventricular valves to be open. Okay, then what's going to happen is the dotted line that we have for our ventricle pressure is then going to become higher around about here than the atrium line, which is now lowering. And that is because the blood is going to be passing from the atrium into the ventricle. So at this location here, which is where there's the crossover, there's a change in pressure. The ventricle pressure has increased higher than the atrium pressure. You are now going to be mimicking this scenario here where the pressure in the atrium is now lower here than the pressure in the ventricle, which is now higher up here. So at this point, the valve, the AV valve, is going to close. So at this crossover point, we're going to have the valve close or closes. So we're going to have AV valve closes. Then what's going to happen is as we progress in time, the AV valve closes so that we can't have the backflow of blood. And then as the ventricle contracts and the AV valve stays closed, then we're going to have a point where this line crosses back over. So as this line crosses back over, we have at this point in time, our ventricle pressure is now lower again than our atrium pressure. So now we are back to this scenario here where our atrium pressure is higher than our ventricle pressure, which is lower. So therefore the valve is going to open again. And that will then allow the process to start of the blood being able to be pumped back into the ventricle. Okay, so that is the valves in relation to the atrioventricular valves, and then we also have valves which are related to the chambers with arteries leaving the heart. So going back to my diagram here, this is my right atrium, and this is my my right ventricle. And blood's going to start here, go down through here and be pumped up through the pulmonary artery, then returning to the left atrium before entering into the left ventricle and then being pumped up through the aorta. So not only do we have valves here and here, which are atrioventricular valves, we're also going to need to have valves here and here. And these are going to be called my semilunar valves. So these here are my semilunar valves. And what we're going to do then is we're going to have a look at what happens here. So when the ventricle is full of blood and is about to contract, we're going to have high pressure in the left ventricle and a slightly lower pressure in the aorta. Then once the contractions happen and blood has rushed through into the aorta, then this is going to change. And we're going to have a higher pressure in the aorta and a lower pressure in the ventricle. And so that valve is then going to close. So let's have a look at that over here. So we're just going to talk about the left ventricle. So this is the left ventricle and the aorta. So in the left ventricle, if we have a higher pressure and a lower pressure in the aorta, the valves will open. And the opposite of that, if we have a lower pressure in the left ventricle and a higher pressure in the aorta, the valves will close. So now going back to my graph of pressure against time. So this is pressure in kilopascals against time. We can now plot our graph with not only ventricle pressure, but now aorta pressure as well. So this is going to be my ventricle pressure that we drew previously. And then now with a straight line or a non-dotted line, I'm going to draw my aorta pressure, which is like this, roughly. So what we're going to have a look at then is we are going to have a look at what happens during the contraction phase. So if we have a look at this location here on the time, we can see that the aorta pressure has reduced, or not reduced, but the ventricular pressure is now higher. So this is my ventricular pressure, my ventricle pressure, which we can remember is drawn with a dotted line. And this is my aorta pressure. So my ventricle pressure is now higher than my aorta pressure, which is now lower. So if you pause the video and just try and explain whether you think the semilunar valves would be open and closed and why. Okay, so hopefully you've done that and you're now aware that if you've got to have high pressure in the ventricle and you're going to have lower pressure in the aorta, that is going to sit and mimic this scenario here where there's this scenario here where there is high pressure in the left ventricle, low pressure or lower pressure in the aorta, so therefore the valves will open. So at that location there, we're going to have the valves opening. And then if we have a look at what's going to happen at this location here, so at this location or this time point, if you pause the video and have a go at explaining what you think would happen here. Okay, so hopefully you have worked out there that the ventricle pressure is now reduced and the aorta pressure is now higher. So the aorta pressure is higher and the ventricle pressure is lower. So then what is going to happen is we are now in this situation here with the left ventricle pressure being lower than the aorta pressure, which is higher. So then the valves are going to close at this location. So we're going to have the valves closing at this location. Okay, so if we look at this here, we've got our atrial pressure representing by this line, our ventricle pressure represented by this line, and our aortic pressure represented by this line. So what I want to do is try and pause the video and try and work out what is going to be happening at A, B, C, and D. Okay, so it's talking about different valves opening and closing. So see if you can recall which valves would open and close at point A, B, C, and D. Okay, so hopefully you've done that and we can get rid of this. So this is going to be the AV valves closing. We're going to have the AV valves opening. We're going to have the semilunar valves closing and the semilunar valves opening.